Hey everybody, welcome to the 1 through 40 cumulative review for our test coming up. And so hopefully you're studying, working hard. And we'll just get right into it. Number one, we're talking about the area of a triangle XYZ. And we're talking about square centimeters, so clearly area of a triangle. You just start by writing the formula. Okay, so there's my base. There's my height, and it's just about as easy a problem as you're going to find on this test. 1/2 of 16, which is 8. And if you want the units, it would be centimeters squared for area. Good stuff. All right, let's go to the next one. This next one, area of a circle with the radius. If you can't handle these problems, we got some bigger problems. All right, area of a circle. So it's going to just, I always start by writing the formula. And you might say to yourself, I know the formula, I can just write the numbers in. I hear you. But it'd be a lot easier to memorize it while you're practicing. So just keep writing it. It'll become part of your memory as you write it over and over and over and over. Okay, so find the area. That means they want us to find the area, leave the A there. 3.14 for pi. And the radius is 4, so just put a 4 there. And then let the calculator be your guide. And that gives 50.24, and then square inches if you're looking for units. Okay. Number 3. All right, these are the fun ones. Okay, so if you remember from our triangle review sheet, which is right here, notice these lines come from the midpoint to the opposite vertex. So in our triangle segment sheet, opposite vertex to opposite midpoint, that's a median. And medians intersect at the centroid, and the centroid is like 2/3. So the shortcut to that, 332-1, says divide your total length by 3, and you're good to go. So what does that mean? Well, that means, let's go back to the review here. That means if I divide my total length, SC, by 3, I'll get the breakdown. So this will be 18 over 3, which is equal to 6. What does that mean? Well, the 18 is cut into 6 and 12. So just divide it by 3. The short piece is 6. The other piece is twice that, so there'll be 12, and 12 and 6 make 18. So this all makes sense. And of course, this is the part they're asking about, CX. So there you go, 6. Find the base of the rectangle here in inches with this area and this height. Okay, so again, by writing the formula down, it's going to be a lot easier. So A equals, for a rectangle, base times height. Now, this time they give us the area. They said the area is 36, so put 36 in there. My base, don't know it, so just leave it as B. My height is 3, so just put a 3 there. And now we'll just divide both sides by 3, and I get 12 equals B. And it'll be in inches, 12 inches for number 4. Okay? Let's look at number 5. It says find the area in square inches of the trapezoid below. Again, this is about knowing area formulas, things like that. A equals, now the way I do this is I say average. You got 2 bases, so take the average of them, okay? Just average the bases and multiply by the height. What is the averaging bases? Well, that's B1 plus B2 all over 2 times H. You've probably seen variations of this, but this is a good way to do it. All right, so take B1 and B2. They don't give us area, so we'll just leave that as A. This would be 6 plus 8 over 2 times the height is 4. So this is 6 plus 8, 14 over 2. So this will be 7 times 4. And you should have had 28 when you multiply all those out. That'd be inches squared. Okay. Number 6. Find the circumference of a circle with a radius of 10 feet. Okay. Again, formulas. Do you know your formulas? C equals, okay, you can use pi d or 2 pi r, either way. They give us the radius, so let's just use 2 pi times the radius. So C equals line up your equal signs here. 3.14 is pi, so 2 times 3.14 times the radius, which is 10. Okay. And that one you should get 62.8. And this is distance around a perimeter, so it's just going to be the nearest tenth of a foot. That's good rounding. And so we'll leave it there. Okay, so that's feet. All right, moving on. Number 7. All right, here's a fun one. It says, given that AC and ED are the same length. Hey, that's cool. Because if they're the same length, now I know by what theorem. I can use angle side is congruent to angle side, AAS. So by AAS, those two triangles are congruent to each other, which is awesome. Okay, so if the two triangles are congruent to each other, then we know that their parts are congruent. Now you could also use hypotenuse angle theorem as well. So make sure you're good with all of that. All right, so now once you know they're congruent, then their corresponding parts must be congruent. What does that mean? That means this piece here has to be the same length as this piece, and this one is the same length as this one. Okay, well it says find the area, so I need area. So if that's 8 is the height for both of them, I just need to figure out this base. So this is kind of a weird one, but what I'm going to have is 6x plus 6, because the measurements are equal, set them equal. Okay. Now, subtract 6 from both sides, and you get 6x equals 2x. Subtract 2x, and then you divide by 4, and I get x equals 0. X equals 0. When you plug it in, it's going to give you take your x, put it in here or here, and it's going to give you 6 both times. So either way, the base is 6, the height is 8, so A equals 1/2 base times height. And let's see, half of 6, that's 24, and yeah, 24. All right, number 8. Let's find a midpoint of a line segment with these points. Now, midpoint is easy, okay? You're going to average the x's, average the y's. Okay, what does it mean to average two numbers? Add them up and divide by 2. So there's your x value. Your y value, just add those up, divide by 2. Okay, so this 14 over 2 is 7, and this is 4. Okay, 8 over 2 is 4. And there's your midpoint. So midpoint's easy, just average your x's, average your y's, and you're good to go. Okay, good stuff. All right, let's talk about this one real quick. It says if some of you guys forgot some of this logic stuff already, consider the following conjecture. If the product of two numbers is positive, then both numbers are positive. All right, what is your hypothesis of your conjecture? What's the conclusion? And then find a counterexample. So hypothesis, that's the P part. It's the part in the front of it's the part after the if there, the if part. The conclusion, or the Q, is after the then. So there's the P and the Q. So this is the hypothesis. And Q is the conclusion. Okay? Now, what is a counterexample? A counterexample is when you make P go into Q, which is a conditional. You want to have a true for P and a false for Q. True goes to false. So let's think of something that is true, that you have two numbers that multiply and make a positive thing, but then both numbers aren't necessarily positive. Okay? So I can think of a counterexample. What about -1 and -7? When I multiply them together, they would make +7, but those are not both positive. So nice counterexample. True for P, false for Q. So try to keep that straight. All right. And yours could look a heck of a lot different there, but whatever values you pick, just pick two negatives and you can do it. All right. Number 10, determine whether polygon ABCD is convex or concave. Convex and concave. Well, concave means you connect your vertexes, and this connection between two vertices is outside the triangle or outside the shape, then it's concave. Concave, I always remember like a cave. Can you draw a little man in the cave? Hey, I'm in the cave. All right. So concave like a cave, convex for most things, okay? Number 11, determine the contrapositive of the statement below. Contrapositive is, this is P, this is Q. Contrapositive is switch and negate, so not P goes to not Q. Oh, I just wrote Q twice. All right, here we go. Not Q goes to not P. There we go. All right, so not Q goes to not P. What does that mean, not Q? Well, this is Q. What's not Q? Okay, so you'd say if a triangle is not equiangular, I'm basically saying the opposite of Q, okay? So if it's not equiangular, then it is not equilateral. Okay? So, easy enough. Just a little short statement, and you're good to go. All right, number 12. Number 12. Hold on a second. Guys, you need to be working on your reviews, please. Thank you. For triangle ABC, let's determine the measure of ACD. Okay, so we're just going to try to figure out what this exterior angle is. There's two ways to do this. Using the exterior angle theorem, you should know that this plus this would give you your total. So angles A and B add up to make that exterior angle. So 45 and 75, that's going to give you a solid 120. Okay, exterior angle theorem. Good, or you could know that this third angle be 60 and that makes a linear pair with the other one, but you get the idea. All right, use the law of detachment. What is the law of detachment? The law of detachment says P goes to Q. Okay, just like we've done, if then. Now they just say, hey, here's a very specific P that just happened. What can you conclude? This is basically saying, hey, if P just happened, now Q must happen. Okay, so all you have to do is state this last bit here with in reference to what they give you. So if angle Y is a right angle, then you can conclude, or you say therefore, as probably therefore, angle Y is 90 degrees, okay? Or you could say measure of angle Y is 90 degrees. Good, and let's find the area of the parallelogram with the height of 7y and the base of 4x. Oh, that sounds fun. Again, write down your formula, A equals, and that's base times height, and the height is like a vertical height, okay? And so we just need to make sure we take that into account here, but I think we'll be good. 7y is our height and 4x. So put 4x here, 7y here. Multiply, you get 28xy, and that's all they want. You're done. Moving on. The area of a rectangular photograph is 168 square inches. And so we've got the length, we've got the width. Let's go ahead and find this rascal out. Here we go. This is a rectangle. I'm just going to write the area of a rectangle formula. Why? They asked for it. And I'm just going to use LW instead of base times height because that's what they're asking for, length and width. So plug it in, plug it in. 168 equals 7x plus 7 times 4x. And now just multiply. Well, what do you mean multiply? Well, distribute. So here we go. 4 there and there. So this is 28x squared plus 28x equals 168. Now, at this point, you got to think to yourself, all right, how can I make this work? What can I do to solve for x? And there's a couple tricks you can do. first of all, I'm going to move 168 to one side. So I'll subtract 168. Because I want to use the power of 0. And because when you have a couple of x's in here like I do, almost left one out. When you have a couple of x's like I do, you can't solve for one of them because they're in two different places and you can't combine those. So you need to use the power of 0 and factoring to do that. Well, in order to do that, I need to probably GCF first. So let's see, 160, I didn't even finish my numbers here. 168, there we go. So 168, does that divide by 24? That would be really nice if it did, or 28, let's see. It does, super nice. So I'm going to divide everybody by 28 first. Okay. When I do that, it's still 0 over here, so that's super nice. So 0 equals x squared plus x, and then I got minus 6. Now you factor. So it's x, let's see, minus 6. So it could be let's see, it must be a plus 3, and x minus 2 would be the factors for that. Now you got two things multiplied to equal 0, so just set each one equal to 0. You could probably shortcut some of this, but we won't do it. X plus 3 equals 0, or x minus 2 equals 0. So one of those two things is 0. We'll subtract 3 and find out. So x equals negative 3. Awesome. Add 2 to both sides, and x equals 2. Now right away, you'd be like, okay, if I were to plug this back in for width, the negative is not going to work. It's going to give me it's going to be a problem. So right away, I'm going to cancel out this one. You could say reject because it's negative. So the answer is x equals 2. Okay. It says provide a justification, so you could just explain all the things I did through words, but there we are. All right. Find the dimensions. The last bit is to find L and W. So let's write L equals, and that's 7x plus 7. So 7 times 2 plus 7, that's 14, and 7 is 21. The width is 4 times x, so x is 2, and so that is 8. So my length is 21, my width is 8. Okay, so it's a long way to go, but pretty easy and doable if you're just patient with it. Okay, what is the measure of CD? Now it's not asking for the length of CD, it's asking for the measure of CD. That's a degrees thing. So if you remember, the central angle is the same as the arc, so this is 125. Done. Okay, the angle's in the center, that arc is the same, 125. Okay, all right, to number 17. Oh, it says let's prove something here. This will be fun, won't it? All right, so we're going to go through our steps here. It doesn't say which way we have to prove it, so we're going to go ahead and do the things we like to do. It says if two lines are perpendicular, they form congruent adjacent angles. You are given that AB is perpendicular to CD, and that 1 and 2 form a linear pair. Okay, so we'll start at the beginning. Always start with what we're given. Okay, and I'll probably make this a little bit simple for you guys. Ooh, I didn't realize this one's so slanty. There we go. Okay, so we put our statement over here, and our reason over here. Okay, so start with what's given. We'll start with the AB is perpendicular to CD. Okay, given. All right, now, because that's given, what do you have from that information? Okay, because they're perpendicular, you know angle 1, the measure of angle 1 equals 90 degrees, and that's just the definition of perpendicular. Okay. You also know that 1 and 2 are a linear pair, so angle 1, angle 2 are a linear pair. Okay, and that is also given. What does that mean? That means angle 1, the measure of angle 1, plus the measure of angle 2 equals 180 degrees. Because those equal 180 degrees, this should be pretty simple. We're going to, oh, of course, that's the linear pair theorem. All right, let's use a little bit of substitution, and then we'll be good. So substitution, what does that mean? That means right here, I know angle 1 is 90. So this would be 90 degrees plus the measure of angle 2 equals 180. That's a little substitution. Okay. And then the last thing you really want to do is subtract from both sides. So then you'll have the measure of angle 2 equals 90. And that's subtraction property. Okay. Now, because this equals angle 1 and angle 2 are both equal to 90, that means the measure of angle 1 is equal to the measure of angle 2. That's the transitive property or substitution. And then you can just say, hey, because their measures are equal, the angles are congruent. Okay, and that is just the definition of congruent. Okay, so there's a little bit to this proof, but it's, I mean, you could tell where it was going before you did anything. Okay, so you just have to like, okay, if I show that this one is this, I have a linear pair, that means they add up to 180. I know angle 1 is 90, therefore angle 2 has to be 90. Okay, so that's all you got to do. You got to give irrefutable evidence for that. Okay. All right, let's keep it rolling here. Number 18, determine whether the pair of triangles is congruent by the SAS. Okay, well, side angle, side. Well, first of all, they don't give me any angles in here, so I got nothing to work with. So no, it can't be. So that's a big fat no on 18. Okay. Number 19, find the unknown length in the triangle below. Well, Pythagorean theorem here. This would be 16 squared plus 30 squared equals c squared. And again, you can do all this left side on your calculator in one step, and that's what I'll do now. So squared, I get 1156 equals c squared. Take the square root of that. I get 34. Oops. So question, do they form a Pythagorean triple? Yes, they're all whole numbers. We're good. That's all it is to be a Pythagorean triple. All right, use ASA to determine the measures of the sides of XYZ. Because angle, side, and angle have been shown to be congruent because it's given, you know that this is for, this longer side is 9, and the side across from the double arc there, that is 7. That was easy. All right. Well, let's keep it rolling here. We're having fun. All right, use a flow chart, give them flow chart proof to write a 2-column proof. Okay, so you're just going to use this to get that. All right, so what I usually like to do is I'll take this train all the way, this part here, you put it in there. Okay, so like angle 1 and angle 1, angle 2 are complementary, and that's given. Okay, angle 1 plus the measure of angle 2 equals 90. That's the definition of complementary. I'll just do a little bit of this, I don't waste your time, but and then so all I'm doing is literally like, okay, I wrote that down and it's reason. I wrote that down and it's reason. Now I'm going to write that one down and it's reason. Write this one and it's reason. Now, once I get those 4 steps in there. Then I'll write these 4 steps, knock them all out, and then you're going to write the last 2 steps at the very end of the proof. So in the interest of time, I think you guys kind of got that writing from one to another. So let's keep it going. Find the value of x in the triangle below. Write it in simplified radical form. Okay, so this would be 8 squared plus 10 squared equals x squared. Okay, so this is 64 plus 100 equals x squared. 164 equals x squared. And I'll take the square root of 164 equals x. Now, is it simplified radical? I don't think so. I think a 4 could come out. Let's see if there's any other perfect squares. What you can do is test different perfect squares to see what can come out of there. So I'll do 164 divided by 4 gives me 41. So if I factor out, I break this up into 4 times 41. That's the same as radical 41 and radical 4, which is the same as 2 rad 41. Okay, so take a second to process that, should be good. And I think that's correct. Yep, okay. All right, next one. You got a banner like a parallelogram. So parallelogram, we got to calculate the values of x and y. So really just, it's situational here, but you've got a right triangle with the 3 sides you're focusing on. So it's x squared plus 7 squared equals 2x squared. So a squared plus b squared is c squared. Okay. Now when you do that, this would be x squared plus 49 equals, and this would be 4x squared. Okay, I'll subtract x squared from both sides. So I get 49 equals, this is going to be, I take one away, this is 3x squared. Divide both sides by 3. And I get 16.33 equals x squared, and I'll take the square root of that. I got 4.04. Okay, it's roughly x there. Okay, so 4.04. Let's see what the y would be. All right, let's look at y here. Now, what you need to know about y is they're talking about the angle here. What do you know about this angle and this angle? Well, they have to be complementary because you have 90 degrees already. So these other two have to add up to 90 to get your full 180 in that single triangle there. So you just have to know that if they're complementary, that means they add up to 90. So just add them up, set them equal to 90. Okay, so this one plus this one. The mistake people will make on this one is that they'll try to set them equal to each other, but they're not equal. So let's do this thing. This is going to be 10y, and 7 minus 9 minus 2 equals 90. We'll add 2 is 92 equals 10y. Divide by 10, so y is equal to 9.2. And that is correct. Okay, so there's my x, there's my y, and I am done. Good stuff. Let's keep it rolling here. Let's look at 24. All right. 24, it says find the arc length L. Okay. And when it's talking about arc length or sector, we're going to use the whole part over whole equals part over whole. Now you say to yourself, well, that's helpful. And it is, because we got this part here. Always start with your degrees. So I got 300 degrees out of the whole. What's the whole thing? That's 360. Okay, so 300 out of 360. And then use your part in your whole. Well, we're talking about the arc length. What is the whole length around a circle? That's the circumference. So that is 2 pi times the radius. Okay, what goes in the top? That is the arc length L, so you can use a big L there if you want. And we'll just cross multiply and solve. So 360 L, I'll just cross them down here, is equal to and then 300 times pi, so just leave pi in there, times r, which in this case the radius is 27. Okay. Now I'll just do a little math and divide it up. We'll take 300, okay, times 27, and then I'll divide that by 360. And I get 22.5, and just leave pi there, equals L. And I think that is close. $22.5. Oh, I left a 2 out of there. So 300 times 2, I was like, something's not looking right. So this is a mistake. 300 times 2 pi times the radius of 27. Now we're looking good. And this is going to be, this should not be that one. It should be 45. That's looking better. 45 pi feet, 49.5 pi feet, 45 pi feet. All right, I think we're good now. We'll pick up with the remainder in a moment. So hope you have a great day. Keep working hard. Appreciate you guys.